Yeah, or the host
Oh
has
no,
to
there.
give you, or I can make you a co-host too, so that way you can also record.
Okay.
All right, so I'm posting the link of tonight's lecture. So the way I do it is I stream it to YouTube, and so YouTube is basically being used as a DVR, for the lecture. So from
Okay.
here on, everything is recorded because I just turned it on, and everything is now being streamed to YouTube.
Okay.
So what we are seeing here, if you guys are looking at my screen, this is the usual site, on Canvas, and I have not been keeping up with my notes. So a lot of the links here, they're linked already, but the all the modules are inside notes of tags. So this is the link that we use to get into um, the folder. It's a Google Drive folder, and what you see inside the Google Drive folder are the sequentially numbered modules. And we are currently on the last module here, which is module 341, and that's IPL. So when you double click on that document, Sabir, let me know if you cannot open the document, because I'm pretty sure I opened it. I shared the document with most people, but
Now it makes sense. I can't. When I double click
oh,
on
you
notes,
cannot. Oh, okay. So I need to add you to that too. Give me a second here to add you to the list. All right. So what is your ID, Sabir?
oh geez, good
Let
question.
me see if I can just find you here. There you go. Okay, I just found you.
Um,
I found you.
all right.
And I'll
Maybe
make you
no.
an editor, because you are teaching the class. So I'll make you an editor. You should be able to open the link now.
Let's see. Okay. Oops. Notes of tags.
Yep. So double click on that and see if you can see the modules listed like this.
Okay, I'm getting all this turn on security. Wait a minute.
I,
Standard
I, I, I
protection.
I promise I did not write any malicious JavaScript code into the documents.
Standard protection. Okay.
Not intentionally.
Notes of tags. Okay. Open notes in a new window. Okay. If I try to do that, oh, that's where I'm blocked again. God. It's like I get another layer blocked and another layer blocked.
Hmm.
Drats. That
Okay.
was no wonder I wasn't seeing the word IPL.
Okay.
Granted, I mean, I know, where it is inside the manual and everything, but uh, there was literally a module you said that was called IPL.
Mm-hmm.
So let me make sure I go pick up a. Let me make sure I do this. First thing I'm going to do is pick up the laptop.
Mm-hmm. Yeah, I think the CIS department may have prepared a laptop for you to pick up.
Okay, got it.
So you can check with Kirsten, because I think Kirsten said that she would arrange a laptop computer from ARC.
Yes, she did, and
Yep.
I kind of called it off because I
Oh.
thought I was like, well, for now I look like I'm good, and now I understand where um
Okay. Gotcha.
there's a little hang up here.
Okay. All right. So it's okay if you cannot open these documents for now, because we are pretty close to the end of all of these modules. What is more important is to go to the syllabus. So under introduction, there's the syllabus, and the syllabus will bring you to an HTML document, so that you should be able to open without any problems. And in that document, if you go all the way to section 20, which is tentative schedule of topics, that is kind of like a rough timeline of how we want to approach these topics.
Okay.
And I am going to basically use maybe half an hour or so, probably less, to finish up IPL today. And the next few topics would be termination and recovery analysis, how do you recover, problem determination tools, and then the next one after that is going to be ZOS installation and configuring, and so on. So this is
Okay.
a list of topics for the basically second half of the semester.
Okay. And you said that's from the.
Yeah,
Let's
these are
see.
pulled from IBM. IBM has so everything about this class,
Mhm.
CISC331, is corresponding to an IBM course called I think it's just called Z System Facilities. I can look it up and send you a link. So that's a standardized IBM course, and because the RSI of the apprenticeship program calls for these, that particular module, that particular IBM class, so that's why I'm including all of these topics. Because IBM said, okay, we would like people to know about these things. So there's nothing here that is customized to the state agencies.
Okay.
They're basically just completely coming from IBM, and it's universal, I guess, to all the IBM clients. But we really don't have the obligation to have to follow it exactly, all the way. So you do have your flexibility in terms of how you want to emphasize certain topics, and also what is more relevant to the apprentices.
Okay.
All right. Uh, yeah. Go ahead.
So you say double click on syllabus?
Just click on syllabus. So in Canvas, okay, so this screen is on Canvas. So under
Mm-hmm.
Introduction, which is the first module inside
Yeah.
CISC 331, just single click on syllabus. That should open it in a new tab.
Yeah, that's where I'm blocked. Okay.
Oh, you're
I
blocked.
thought yeah. I
So
really
so
do
they so
apologize.
they specifically just let you visit a particular link that has
Exactly.
lrccd.instructure.com, but they won't let you do anything else after that. That
Yeah.
is
And I thought,
just
yeah,
weird.
that's a mess. I'm sorry about that. I apologize.
Okay, well, it's
Yeah, that happened. That's not the first time it's happened though.
okay.
Not for this type of thing. Yeah, it is.
Okay.
But I've taken courses for some for things, and oh, okay, everything's through, and then all of a sudden,
Okay.
boom. Yeah.
All right. So I guess what we'll do today is really just kind of let me kind of recap what we have already talked about in IPL, and then I'm gonna finish up the rest of the topics for IPL, and then I'll let you Sabir, to get started with the next few topics, and you can do it any way you want. I mean, you can just bring up some IBM documents, or all whatever documentation you find. You just need to share those documents with with the students.
Okay.
All right, so I'm gonna get started with basically recapping what we talked about last week, and for those people who are feeling kind of not well today, it's okay. It's everything is being recorded, so if you need to kind of check out, that's probably okay. All right.
I
So
think I'm gonna do that, Tack.
okay,
Thank you.
you're welcome.
And it's all being recorded, and I'll be back on Wednesday, Sabir. Thank you. Nice to meet you.
Nice to meet you, Kelly. It
Okay, you guys.
will.
Okay, thank you.
All right.
Bye.
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 All right. So last time we talked about second stage, what I would call second stage bootstrap, in the IPL process. And in that particular process, this IEA IPL 00, which is a certain portion in on a cylinder, on cylinder 0, after track 0, but how much after I do not know. So that portion is going to be read into physical memory, and instruction execution will continue to this portion. So the first portion, before that, the first stage of the Bootstrap is to read track 0 of cylinder 0 into RAM and then start executing over there. And then the second stage is to load this extra portion into physical memory and then continue to execute in this second portion that we are reading in. And also last Wednesday, I kind of mentioned why we have these multi-stage Bootstrap. Why not just with one single read, read everything in and then just be done with it? Well, part of it is backward compatibility, so there's probably some kind of legacy code with the firmware that is only capable of reading track 0 by itself. So track 0 has to include the instructions, the computer program, a very small computer program, to read the second portion, which is going to be larger. It has to know where to find it and read it into memory. And then when we start to execute the second stage, which is basically the image or the binary content of IEA IPL 00, it would do the rest that we talked about last time. So it would basically assess the physical memory, or in IBM's term, real storage. Actually, it's I'm just thinking, it's not real storage, because real storage refers to both memory and disk. So we are talking about just memory here. So it would basically have to check out how much RAM is actually installed on the mainframe, because that number is not actually pre-programmed. It's actually something that can change over time. And also, if you consider that this instance can be a LPAR, can be a logical partition, that really kind of adds another layer of variable to this whole equation, because you really don't know from the perspective of the LPAR. The LPAR itself does not yet at this point know how much RAM is installed in the system, so it has to go scan and find out how much RAM is actually installed. The control program, this IEA IPL 00, is also called a control program, has code that understands how to locate data sets in the volume. So at this point we have some rudimentary capability of reading the content on the DASD. Because that is needed in order to locate a specific dataset called CISC.nucleus. So the term nucleus, we talked about how the term nucleus really means the most core portion of an operating system. And last week we talked about how the operating system starts with the nucleus, or in more modern terms, in Linux or Unix, it is called the kernel. So outside of the kernel, we have some additional components, and then we have the shell, or where the user interaction is actually pretty is very on the outside of the operating system. So this is really the center of the operating system. So at this point we have the ability to read, to locate, a dataset on the DASD based on its name. And we are also going to set up the basic kernel, by reading and executing multiple IRIMs. So IRIM is the abbreviation of IPL Resource Initialization Modules. Okay, there we go. And this is a very IBM thing, because it's an acronym that includes another acronym. So it's just kind of interesting from my perspective. It's kind of like recursive abbreviation. All right, so at this point it's going to interpret the load param, and I was corrected. I spelled PARAM, and it's actually just PARM. Go ahead.
Well, yeah, it's load parm. Well, that's how they'll always say it. Load parms.
Just load parm. Okay.
Yeah.
No, you can, if you want it. Please feel free, to add to what I'm saying here, because as I said, I have no experience of using IBM mainframe computers.
Yeah, no. You're doing fine. I'll be honest with you. As far as like the system to the guts, like the people at the data center,
Mm-hmm.
I've never had the true full authority that they've had. So uh, throughout my career, but I've been working on the mainframe so long, so a
Yeah.
lot of these terms are thrown around. So yeah,
Okay. Thank you. So by interpreting low parm, it will find IODF, and then it also would low parm would also specify which configuration we are supposed to use in IODF. And I believe IODF was explained somewhere. I cannot remember where I explained it. Um, I think it's input output definition file, um, and which is the only time that IBM refers to the name of file, or very few times that IBM refers to the name of a file. I'm just looking this up on the side because yes, it is input output definition file. So what?
definition file. Yeah.
Yep.
Okay.
Instead of definition dataset.
Mm-hmm.
That's kind of, yeah,
I know.
just kind of
There's
interesting.
just that's typical IBM.
Well, it's a
Or
huge.
sometimes they'll say data facility, and you're like, wait a minute. Uh, what's the difference?
Well, it's a
That's
huge corporation, right? I mean, it has a
yeah.
lot of products, and this kind of stuff is just bound to happen. And then it will check the existence of these files. So it's going to check the sys0.ipl parm, and if it doesn't exist, it will check sys1 and then sys2 and so on. And the last one it's going to check is sys9.ipl parm. If none of those exist, then it's going to go for sys1.parmlib, and hopefully one of these would have would have a configuration, would have a set of configurations specified, and depending on how low parm is specifying which setup or which configuration we want to use, then it will read only that specific configuration to continue the rest of the IPL process. So at this stage, the nucleus, which is read from sys.nucleus, is going to be loaded into physical memory. And it's a very important point here as well, is the nucleus of an operating system cannot live outside of physical memory. In other words, it cannot be partially in virtual memory space. It cannot swap out, cannot page out. So this portion is always in physical memory. Um, and then from here on, it will start to initialize virtual memory, and basically it will allocate the space for the system queue areas. There are three variants. There's the regular, there's the extended, and also the local. And C address space map. That's because when we talked about um, all about jobs, that's when we talked about address space. And one of the links, links to an IBM document that includes a pictorial representation of how the address space is set up. So there are three different regions, of SQA. There's just the SQA. There's extended SQA, which happens after IBM extended its architecture, and there's also a local SQA, which is also known as LSQA. And then it would also initialize other things. It would initialize physical memory management data structures. So these are the things that is needed in order to implement virtual memory. The page frame table, okay, let me just kind of see if you guys still remember these terms. A page refers to what in the whole memory architecture. In other words, does page refer to 400
Virtual
and
memory.
virtual memory? Very good. Good job.
Uh-huh.
What about frame?
Frame refers to physical memory.
Exactly. Okay, good job. So page is from virtual memory space, and then frame is from physical memory space. So the page frame table is a lookup table. So this way, when a program, when a job, which is executing in virtual space, says, oh, I need to access location, 200, okay, for instance. Um, the instruction set, would basically eventually boil down to, okay, that's just virtual address, which is not what we need in order to execute the instructions. So it's going to go to the page frame table to see if that frame is already in physical memory, because it is possible that a page does not have a frame corresponding to it. So in the case that a page does not have a frame associated with it, then the operating system, to be more precise, the nucleus of ZOS is going to look through all the pages, look through all the frames that are already loaded, and figure out which one it can be paged out in order to make room for this, basically pending request to come in, if it's out. Now, on the other hand, if you have physical memory frames left, it will most likely just pick one of the free frames left and then make the association. And then also at that time, it will have to go to the I/O device in order to load that content into physical memory. So here's the question: what is what? How do we call this block of content when it is on an I/O device? There's page, there's frame, and then there's one more term to refer to the 4K.
Slot.
It is a slot. Very good.
Slot.
Good job. All right. So you guys did pay attention. Or you learned this from somewhere else. But good job. Good job regardless. So there are also segment tables, and there are two footnotes here that point you to more about segment tables. So from what I can gather, a segment table allows basically a subsystem to share data, through shared memory with the jobs and other applications. So that's my understanding. And then the most important part is the master scheduler also has its own segment table that's also initialized at this point of the Bootstrap process. All right. So now this is the fun part. Because track 0 of cylinder 0 was initially loaded starting from location 0 of physical RAM. That contains the Bootstrap code to get to this point, okay? But at this point, now that we have already loaded the nucleus into memory and stuff like that, it is not needed anymore, because that process is already done. So instead of using the location 0 area to execute a code which is no longer needed, we are replacing it with PSA, which is the prefixed saved area. If you look up the memory, the address space mapping, this is at the lowest portion because it starts at location 0. Now the other part that is interesting about PSA, even though I don't fully understand why it is CP specific or central processor specific, is that it is central processor specific. So it does tie into which processor that area is associated with. And then the very last IRIM or IRIM, I suppose IBM is gonna make it pronounceable as IRIM. So the last IRIM is gonna load the first part of the NIP or the Nucleus Initialization Program. So that would be the third stage of the Bootstrap process. So at this point, once the Nucleus Initialization Program starts to run, this really is part of ZOS. All the other stuff is kind of not exactly ZOS, because the nucleus is, but the rest is really kind of very rudimentary setup to get the operating system running. So that would definitely be the nucleus or the very kernel part of the operating system. But at this point, when the NIP starts, it would run in resource initialization modules as opposed to IRIMs, which is IPL resource initialization module. So these are not IPL specific, and these will start communication with the NIP console. I would imagine that some of you have seen a console, or a virtual console, most likely on a Windows machine. That displays the rest of the Bootstrap process, or messages from the rest of the Bootstrap process. Is that true? Has anyone seen a NIP console?
No.
No. Okay. Well, I suppose you can look it up. If you look up, and do a Google search on NIP console IBM, you'll probably find screenshots of the NIP console. So, so in the good old days, okay, before we have virtualization and all the other technology, it's only at this point that an operator can see something and can start to interact with the system,
Are
because
you
the
talking about the external screen that's actually on the mainframe?
um does a mainframe have a screen? Because
Yeah,
most mainframes do not have a screen linked to it.
yeah, they have an actual, from what I understand, they have an actual console
Uh huh.
that's on the mainframe that the operator uses when they're doing the IPL and everything.
And is that called the NIP console?
I don't know.
Okay. Let me check out some images so that you guys can see what it looks like.
Loopy might remember the name of it. I'm not sure.
believe it's called an HMC.
The HMC is the hardware management console, right? And that's the very first part of this of this discussion starts with that. So the HMC, or the hardware management console, was the very first thing that we used to start up, and that, I think, HMC is tied into the Type 1 hypervisor. Can anyone comment on that? Because this is when we can specify which IPL volume we get to use, to start up this particular LPAR.
I do not know.
Yeah, because HMC is not it's called a console, but it's not a console in the 1960s sense. Okay, I can look this up. So if you look up IBM HMC,
It was tied to the MVS time days, really.
oh, okay.
Yeah. It's used during initialization, but I'm trying to bring my memory back here, so bear with me. Go ahead, Tech. Sorry.
No. Because I'm not familiar with which term refers to what in the IBM world. Okay, there we go. How to initiate a resource dump from the HMC, and it has a screenshot here. Does that remind you of? So this is hardware management console workplace, and this is definitely GUI based, and it is going through Firefox. So this is a web client connected to the. I would imagine this is connected to the Type 1 hypervisor PRSM, because it's giving you a view. It's almost like a VMware console, where it gives you a screen to help you configure how you want to set up the virtual machines, and how you want to how what kind of parameter you want to specify when you start up a virtual machine. And as opposed to the other types of console, let me look up the other types of console, because I want to contrast the two kinds of consoles, because this is called a console. Um, and Sabir, you said MVS had HMC as a console, had HMC already.
Well, the word was interchangeable. They used to say console ops, but it was a dummy terminal. But
Right.
yeah.
Huh. Then what is a NIP?
Way under. Let's see. I'm looking it up too. That's
Because
not
I think
okay.
because I think all the images that I could come up with NIP, those are dumb terminal screens, as opposed to something that looks kind of like a GUI interface.
Use it. Yeah, the no nip console is defined and ready for. We use the nip time console. First. So the nip console is defined and ready and to be used during initialization.
Right.
MVS will not switch from one console to another during nip. Well,
Okay.
actually, it probably does that on purpose to avoid that, which is part of the whole bootstrap process.
Right. But the
Yeah.
nib is not even active until this point of time. So until we are at the third stage, close to the end of the third stage of the Bootstrap process, in the good old days, before HMC, before a Type 1 hypervisor, the operator would have no interaction with the system until we get to this point. So when the nib starts, it would run these things, and it would potentially let the system operator to specify additional parameters. Otherwise, it would use IEA CISC NN, being 2 digits, in sys1.parmlib. So only at this point, it would start to have the ability to interact with a human to specify, how the rest of the system should start up. Well, that's my understanding, which is, kind of, dubious to begin with. Alright, so at this point, it would create and load into the various link pack areas that collectively implement common reentrant modules, including SVC routines. So does anyone remember what SVC stands for?
Is it service call?
Yep.
Yep. That's what I was going to say.
And does anyone remember what service calls are for? What is the importance of service calls, and how does it relate to interrupts?
Lupe? Help!
Okay, so no, it's okay. I just want to see if you guys remember that stuff, because that part of the discussion was kind of abstract. SVC is also an instruction in the IBM instruction set or the architecture, and it is also called a software interrupt. And as a software interrupt, this is the gateway between a job or an end user application or even the subsystem versus the operating system. So if you want to draw a line and say, on this side we have jobs, we have applications, and we have subsystems, and on the other side we have ZOS, the interface is the SVC calls. So every SVC instruction is a software interrupt, and as a software interrupt, it would basically go through the same motion as an actual hardware interrupt, except this one is synchronous, which means the program knows exactly it's me executing this instruction in order to trigger the mechanism of an interrupt. But the reason why we want to do that is because we want to get the attention of the operating system, and so that the execution of the code in the operating system can execute in what we call a privileged mode, as opposed to the unprivileged mode when an end user program runs. So once it switches, because of this instruction into the privileged mode of execution, the operating system now has access to all the I/O devices. It has access to all the actual locations in RAM. It can interact with all of the parts of a mainframe, as opposed to the unprivileged mode of execution of a normal app and a normal job, because you don't want one single normal job to wipe an entire DASD. You don't want it to crash the entire system. You want it to, in the worst case, just to crash itself. So that is the significance of the SVC instruction. And when we refer to the name SVC routines, these are the handlers of the software interrupts. In other words, when an application says, okay, system, I need you to do something, it would basically use what we call registers to specify what the app or what the job needs. These routines are specify the logic of handling those requests. So that is the significance of SVC, or service call. The link pack area is basically a collection of these SVC routines. So this is another layer of the operating system where it is starting to define the interface between ZOS and the rest of the world. Okay, basically, the jobs, the applications, the subsystems, and whatnot, because all of those parts, of a mainframe system would interface with ZOS through some kind of SVC routine, and that is the significance of the LPA, or the link pack area. So the link pack area contains the code, and by comparison, the CSA, or the common surface area, would contain the data. And that's basically from what I read in footnote 10, that the CSA contains the data area related to system calls. Is it system call?
Service
Surface call.
SVC.
Yeah.
Service calls. Yeah.
Surface call routines. So in other words, at this point, once we get past this point, the ZOS now has the ability to talk to the subsystems, because this SVC surface call is the interface, is the key interface between what we consider as ZOS and the rest of a Z system. So the rest of the Z system would consist of the subsystems and also the jobs that are specific to each client. Like, the franchise tax board would have their own jobs, the DMV would have their own jobs, and so on. The subsystems are still usually products of IBM, even though it is not necessarily the case, because Oracle would also be considered as a subsystem. So in this case, the master schedulers would start first. The master scheduler is one of the subsystems, and then it would be used to initialize JAS2. Typically it's JAS2 with most mainframes, and I think JAS3 is not used as much. And then the other subsystems, so that would include DB2, CISC, IMS, and so on. So at that point, okay, once you have JAS2 running, and once you have the master scheduler running, then we can start to have jobs to be scheduled, and then you can start to run your normal, quote unquote, normal client specific jobs. Phew. Okay, so that's the end of IPL. Any questions?
I can actually, if you guys want to see what a IPL would look like, Tech, I could kind of show you on my screen.
Oh, absolutely. Let me.
I mean, don't get me wrong. I'm not actually doing an IPL, but I can give you the IPL information.
Yes.
So
see if you can share the screen. If I stop sharing mine first. Okay, so let me click that. Okay, I have to stop sharing screen first. Okay, there we go.
Okay.
Click that button. There we go.
Right.
Can you share?
Okay, let's see. Host disabled participant.
Okay, so I'm gonna have
sharing.
you configure you as a co-host. Give me a second.
Oh, that's right. Yeah, that would make sense.
Alright, so right here, make co-host. There we go. Click yes. Alright, so now give it a try. Alright, that works.
Can you guys see that?
Yep.
Yep.
All right. This is just a simple command that you could learn, and you should be able to have access to if you have access to a mainframe at work. It shouldn't be a big deal for this, but you may have to be. I'm swearing you guys to secrecy here. So basically, at the data center, this is what all I'm doing is a TSO space IPL information. So it basically gives you a rundown of what we're talking about. Tells you, of course, what day it is, and then it tells you when the last IPL was, and basically it was 7 days ago. They do it twice. Basically, they do IPLs everywhere I've ever been 2 times a month, unless something special happens where they got to do it more often, where they got to do a whole system load and do an IPL. But those got to be coordinated, of course. And this is where all this information is it's just loads and loads of information of telling you what LPAR it is. In this case, They're telling you, you can see the Z architecture, the processor name. Our particular L part of my job is called S1S1. That's the one I'm doing it from anyway. There's more than one.
Is your S1 on our mainframe at CDT?
Yes, you guys are. It's Vacaville.
Right. I work on a S1. I do some
Oh,
jobs
okay.
and stuff
Great.
for my unit. So, yeah, okay.
Great. And that's what all this information comes from, and it's just loads and loads and loads of information.
Oh, this is good stuff. This is really good stuff because it really relates back to the stuff that I talked about, like the CSA, the SQA, where it is and how big it is. This is really useful because SQA size greater than 16 megabyte. That's the extended SQA.
Mm-hmm.
Yep.
Yeah. So, in a nutshell, and that's why I was asking you offline, Tech, about I was assuming that the course was set up where it was there was virtual machines set up through IBM's site or whatever. I didn't know, so I was just curious.
Yeah, that's something that we're going to talk about today. Mark and I are going to talk to some people from IBM about possibly having them to set up some sandboxes for us.
That should be fairly easy for them too. I mean, I know they do it all the time. God, I went to their lab only like a year ago, and they were talking about how we have all these virtual machines for people to have access to. Obviously it's probably some type of an agreement between an agency / company,
Mm-hmm.
or training. Usually it's trainers, a lot of these trainers, but all they are is usually just a web link. Click on them and it's a virtual machine just like that, set up for people to use.
Mm-hmm.
So that should be fairly easy for them to set up for everybody.
Cool.
It should be. I don't know what they're gonna go through. I don't know.
Right, that's really kind of the thing because they also need people to help set up these virtual machines. So who is going to help administer these things? Who's going to help reset everything back to square one, and so on, and how can the instructor get into the system of a student's sandbox? So there are all kinds of consideration. And I'm not sure IBM has a special department just for that. So these are all the things that we're going to figure out tomorrow with Mark and a person from IBM.
That'll be great. It'll be easier for you. It'll be easier for everybody, actually.
Yep.
Just to see it go. I mean, even if it's just a simulated event, of an actual IPL. So, I mean, that's just as far as IPLs go.
Yep. I also talked to the class, and many people expressed that they probably would not have access, or the necessity to go through IPL. So the other thing in the long run that we'll be addressing is how do we make the content of this class more relevant to the apprentices. And I've been starting to collect statements, job statements about what they are going to do with their after the apprenticeship. So I think that would be helpful too, because right now we are just going for the plain vanilla IBM template of how they think a system administrator is supposed to know.
Exactly.
All right, so I'm out of material. I'm out of material. So right now we're moving on to termination and recovery analysis. But I have no material for that.
Pass over. No, I'm kidding.
Well, we're gonna see how what kind of rabbit Sabira can pull out of the hat.
Well, termination and recovery. Let's see. Let me see your syllabus here. If I can see anything of it. this is really embarrassing actually, but it's an environment issue.
I think we can basically start to think about this as how can you tell whether a job terminated successfully? How do we know that a job is done and it is normal and everything is good to go?
Right, this condition code.
Condition
Okay.
codes, yeah. Um,
Is it also called a
Obviously,
completion code?
Condition code, yeah. It's referred
or
to as
complete, or completion. It depends on who you're talking to.
Okay,
Yeah.
so they mean the same
Return
thing.
code or return code. There's a million different quick names for them.
Okay. So now the next question that I have is how many ways can a program not terminate normally? So I can think of at least two ways. A program can basically just try to hog more resources. So I want to output more stuff to the output, data set, and I'm not going to respect the parameter, already set up in the job card. So in that case, if a job is not behaving, and it's up to the operating system to go like, nope, you are terminating now. In that case, how can an operator know about the job is terminated by the system because it was trying to use more resources than allocated?
wouldn't it be by the condition code that it throws?
So the condition code is going to be thrown by the operating system, right?
Yeah, it's taken. I think what you're asking here is it's taking up more resources than it should, or it's the IO or CPU is going through the roof.
Right.
Well, like, I'm sorry, I don't mean to interrupt, but like,
Yeah, no,
No.
go ahead. This
before,
is a discussion.
in my prior class, I got stuck in an infinite loop,
Mm-hmm.
and
Yes.
because the system has limits on it, it would automatically terminate the job.
Okay.
There you go. You got a time parameter too. Yep.
It was using so much CPU that it automatically stopped the job.
Okay. So now I'm going to ask more questions. When the system stops a job forcefully, in other words, it's not waiting for a job to terminate, voluntarily, does the system leave behind what we call a core dump? In other words, does it leave behind a trace so that people can look at that trace and figure out, okay, where is that infinite loop? What was the last instruction that executed before the job was terminated by the operating system?
I can't answer that.
Well, if it's a job, okay, let's just say it's a person's job.
Mm-hmm.
It'll be in the held input or output queue. Or, it could just be, it may not, and it might just be in the system log. Depending on, who owns the job, if the system owns the job, but the system log will have it either way.
Yeah, so I'm reading.
But the real detail of the system log, yeah, it may be extracted into SMF records depending on what the job is. Yeah.
Mhm. I'm
Most
reading
of the
on.
time when I've seen a job fail,
Uh-huh.
it throws an error code,
Mhm.
which the first three letters of it, I believe, associate with a particular system, and then you can throw that error code into do a Google search on it, and it'll tell you specifically why the job failed, and it will also tell you at what place that it failed.
At what place? Just from 3 characters, 3 letters?
No, it's generally 3 characters I believe, to identify the system. Sometimes it's four, and then there's additional like 4 or 5 characters after that to specify. So it'll say like the first three, if I'm thinking properly, the first 3 characters identify the system or subsystem that
Mhm.
had the problem, and
Mhm.
then the next characters after that identify what the specific problem is. So
Loopy, is that when you're looking at the output and then you can put your cursor underneath that error code and do a QW and it'll tell you what the error is?
I'm not sure about the QW, but I know it shows up in the logs as well when you're in SDSF. it'll show up there. But I've seen them pop up initially on the terminal itself.
Interesting. Does this in any way relate to append?
Yeah.
Yes.
Abm would be an abnormal end. So.
Mm-hmm. Okay. Yeah, there's such a thing called an append dump, and
Yeah.
it's so the concept of a dump. If for those of you who are not familiar with the term, it basically just takes the entire almost not I shouldn't say entire, but it would take all the relevant part of the address space and then put it into a basically a huge data set on the DAS-D usually. And what it does is it's capturing a snapshot of the program that the system decided to terminate. And typically, if you send that dump to the developer, you know, um, typically, hopefully, it will help the developer to find out what was the last instruction that executed, before the system intervened and go like, okay, this job needs to stop. And also, because the developer would be able to map the machine code which is contained in a dump back to the source code, which is, I guess, most of the time written in COBOL, so that they can figure out, okay, I was stuck in an infinite loop, but I could tell at least, the infinite loop is here, and then they can make the changes, and hopefully they can submit the job again without the infinite loop.
So my understanding of that type of scenario is like when you have a system dump, then it's like there might be something wrong with the product and then the vendor, we have to get the information off the system to provide to the vendor and then see why it didn't work properly. Like it could be because a fix wasn't applied, or there's a fix out there that has to be applied, or it's a new error that the vendor is not even aware of yet with something wrong with the product. Right? Kinda.
Yep. Well, the whole
Well,
the
it could be
idea.
a product problem. I mean, yeah, just depending on what caused the dump. There's
Yeah, there.
especially for if you're from CDT, correct?
Yeah.
Sorry, is this Jennifer? Oh, it's Carrie.
Yeah.
Yes, so you definitely more likely from the system programmer side, you probably would look at a dump. What caused this dump? Oh, it wasn't a job I ran, and then it would be some type of fault analytic thing, and it could be an actual product causing that's having the issue, and if there's an issue, when or why, and which is all going to be something of opening up a ticket. I'm trying to cater some of the questions and massaging the answers towards what you guys are actually going through at your job. But yeah, from the system side, yeah, that would be one reason. That definitely would be one reason.
I'm just looking at all the variations, all the different types of dumps. So there's a SVC dump, there's a transaction dump, there's a standalone dump, and there's an append dump, and there's a snap dump.
Can't help you there.
But the append dump is probably the most relevant one, because I think the append applies mostly to jobs. Whereas a SVC dump is at a system level. In other words, if ZOS itself is experiencing some problem, then it will be an SVC dump because it's impacting the system itself. All right, so if a job doesn't run completely, doesn't run correctly, what do you guys know what will be done to the job? Okay, first question is, how do we know that the job did not run to completion correctly, and whose job is it to check?
I do that on like a daily run jobs
Okay.
for our system for our database and like the backups and P logs and stuff like that. And I have to go through and review after I issue the command to run jobs. Then I have to go check all the completion codes,
Mm-hmm.
and if there's anything higher than a 0 completion code, then I have to go look at the job output and determine what happened with the job and why the job failed. And then I compose a report to the unit. But normally it's um, like today, for instance, I had a condition code of an 8 on a file. Well, the job, not the job itself. And what happened was it was because the system was IPL'd on Sunday. So the P log filled up, and then it ran on Sci 7, and then it tried to run it on Sci 5, but it was all because of the IPL. So there was nothing that we had to do to correct it, but we have to determine what the problem was. And but sometimes there are problems where like somebody did an upgrade and they they did the proper jobs on one of the systems but forgot to flip Sci 5, but they only did it on Sci 7. So then like when those type of errors are identified, then the person who did the upgrade on the product has to go fix the issue. So then the error code won't be thrown next time run jobs is done the next day.
Okay, very good. Thank you, Carrie, for the detailed description.
So
So so you mentioned a specific return code or
Condition code.
condition code of 8. So is it a standardized code that 8 means a particular thing, or is it specific to the job that is being run?
it's specific, from my understanding, it's specific to the job being run, because like a condition code of 4 is a warning,
Mm-hmm.
but not necessarily any action has to be taken. And then a condition code 8, that's like what I had today. But then there's also can be JCL errors. It'll throw JCL error. And I believe, and I'm not correct, I haven't seen it, but I think a condition code 12 is an adbend.
Okay.
Maybe Sabir can answer that question.
I'm actually looking at a return code. It could be a lot of different things depending on also how the application that's running. But yes, you got 8, 12, even 16s. 4 is generally a warning. Now, warnings could be acceptable depending on also the JCL or whatever products you're, whatever we're talking about here. Sometimes like, let's say a ChangeMan is an application that's installed on, ChangeMan is a software tool tag that we, a large it's a change versioning tool that's used for the state.
Mm-hmm.
And some like, well, at least for EDD uses it, Department of Healthcare Services uses it. Just a version tool. That's all it is. Version control tool. Most people are use Endeavor by CA. Let's just say, for example, when you're using that tool for an audit, when you have to run an audit before you install what it calls a package for you updated a program, for instance. A 4 is acceptable in our case, but depending on how you configured the tool and what is acceptable for the install, 4 may not be acceptable. So yeah, generally 4 would be, for a general sense, you would say 4 would be empty. JCL error usually will be data set not found. Usually, that doesn't necessarily mean it always is. There's so many variables on the, in the mainframe world. But return code 12. When was the last time I saw one personally? VSAM file. I think I had one the other day. I think it was just not access to it. That's all it was. It was basically It was a basic access authority issue for me on that one.
I'm looking at, there are many different codes.
Oh yeah.
And so the document I'm looking right now is DFSMS DFP checkpoint/restart. And I guess it has its own reason code and also the append code. So within so after reason code, there's also an append code, and it tells you what potential problem it is indicating. I'm gonna put it into the channel chat, so you guys can kind of click on those links if you want to. I'm not really sure about the relevancy to the topic that we have at hand here, which is termination and recovery analysis. Okay, so
if you look in that first paragraph of that document, DFP or there in there, you'll see that it has on the second line it says IHJ and then XXXX, and then that's where the reason code is submitted. That IHJ is specific to this DFSFM DFP.
Okay.
So I was saying, that throws error codes. So it has that particular, that's the 3 letters for this particular system when it's throwing those error codes.
Gotcha.
That's kind of the general format of them.
Okay.
Did you show that tag? Because I didn't see that.
It's in the channel chat.
So
I
here
just happened to be looking at it right when you were looking at it. So
I'm gonna put a link in the channel chat too, and it's condition codes, and it kind of gives a breakdown of what they are.
Okay.
Yeah.
Okay, that would be helpful. Let me show Severe, what we are talking about when we say channel chat. All right, so this is the Zoom interface. Oh, let me do the screen share first because it's not being shared right now.
Sorry about that. I was just thinking it was in the chat room. I mean, so I thought the links would just be in there. I thought that's what you guys meant.
It's on the bottom of your screen if you hover at the bottom, and
Okay.
then there'll be something that says chat
Okay.
next to participants, and if you just click on chat, it'll open up a window.
Oh, there they are. Got
Yeah, and if you click on my link, then you can see what I was just stuck in there. I don't see tax link.
Are we talking about the channel chat? Or
you're talking about I put it in the chat in Zoom.
Yeah,
No,
the channel chat is nice because it is persistent.
All right, I'll put it there.
Yeah. Sabir,
There
do
you
you know
go.
how to get to the channel chat?
No, actually, I don't.
Okay,
Let's see.
let me show you. I can do the screen share and then show you how to get there.
Okay.
Give me a second here. Yeah, this is a feature that I discovered when I was trying to set up for this class. Because for all of my other classes, I use Discord, and then when I heard about people using, state agency issued, computers, I go like, no, that is not going to work.
Yeah.
Because people cannot install additional software, especially Discord, because a lot of people just say, Discord? Are you gaming?
Yeah, exactly.
Yeah. Give me a second here. I have to go find the right window to share. Alright, where's my OBS? Oh, there we go. Alright, so I'm sharing my screen right now. Hopefully you guys can see it.
Yeah.
Alright, so this is your usual Zoom interface window, right? And this is the usual chat, that is used, for, oh no, I take it back. So to get to the chat, the channel chat, you go to the chat tab, which is here. And then in recent chat, you should see CISC331, and the red one here means I have not read the last message. So when I scroll down to the last one, I should see Carrie's link right here. So if you cannot find this, okay, if it does not appear in your recent chats, you can go all the way to contacts, and then within contacts you have two tabs. You have contacts and you have channels. Click on channels, and I made sure everybody is added to the channel. So under channel, you should see under all channels, you should see CISC331, and then once you get there, there's a little icon, a little chat icon right here. Click on that icon, and then that will bring you to the channel chat for sure.
Hey, my name is not there.
Your name is not there? Okay, let me double check. It's here.
Right there.
Yeah, it's right here. These are the members, and I appeared twice because I was trying to make sure that this works. So I was using a student account as myself, and then I was using my professor account as myself here. So this way I can be sure that this mechanism works.
Okay, so how do I get to that Zoom channel then?
Okay.
Because
So you go to contacts.
Do you have the Zoom on your desktop? Because I had to install it.
yeah,
So the question is, are you using a web client, or are you using the application, a desktop app?
I just clicked on your link is all I did. Oh, there's the see, return to meeting. Okay, chat.
Yeah, if you did not install the desktop app, you may not be able to see it. So you have to install the desktop app first. All right. So until Sabir gets the desktop app installed, I guess we can copy and paste all the links to the regular chat channel.
I thought it was on there. Okay. Join a channel. Okay, what's the channel?
You should be in the channel already because I added you to the channel.
Okay. All right. Let me not deter you from your flow here. I'm trying.
Okay.
Or did you click on the link? Wasn't it in the channel?
I clicked on a link from an email from
Oh, it was an email. It wasn't in the.
From Tax sent me.
Oh.
Yeah, you need to add the desktop client. Download that. Because that happened to me. If I just click on link, I won't be able to see everything.
That happened to me too.
Yeah, I'm quite a troublemaker here because I'm using some feature that the web client of Zoom does not support. So, Sabir, if you have not done it, you can go to the download center of Zoom, and obviously you're not going to be using Linux, but once you get to this page, it will pick the right operating system for you, and then you have to install the app. Not sure whether you can do it with the EDD computer, but you should be able to do it with the ARC machine.
Got it. I'll try. Yeah, I'll try anyway. Worst you can do is block it anyway. So go ahead. Yeah.
Okay, so that means here for now we will just use the regular chat and not the channel chat. The channel chat is really nice, from my perspective, but you guys can do what can do this however you want because the channel chat is persistent. So if I go up, I can actually go to the previous class and the class before that. So this way, the conversation, past conversation, using the channel chat channel, can always be referred to without having anyone to have to save the document, the chat text to somewhere. So
yeah, that's also where you put the recordings, so then we can access them at our leisure.
Right. So today's recording is already posted here. So that's today's link to the YouTube recording. So that is also helpful because it's always going to be there. And unfortunately, a lot of people do not use channel chat, and I think it's not a very well developed portion of Zoom. All right. So getting back to the topics. All right. So the topics that we are currently on, and I'm okay with today's class ending maybe a little bit early, because Sabir is really just trying to get onto the system, so it's probably okay to end the class a little bit early. But basically, this is where we are at. Termination and recovery analysis. So we have recovery processes. So termination analysis is just what you guys have just talked about. Is look at the code, figure out what is wrong with it, and then get it reported. Um, the next topic is going to be recovery process. How do you what does it mean? Okay, when they say recovery, and then the second one is once you recover something, how do you continue the job? Is a job continuable? Can you continue a job that has been terminated? My guess is not. But I'm not really sure what they mean by recovery.
Well, in my mind, when you say recovery processes, what comes to my mind is if you accidentally delete a data set, you can recover it,
Okay.
even though you accidentally deleted it.
hmm Now, what about in the situation where it takes too long for a job to finish? If I remember correctly, there are checkpoints within the execution process. So if a job takes too long to complete and the system decides, okay, you're taking too long, I'm going to have to terminate you. In that case, do we get a partial result from that job?
Yes, and we can rerun the job with the restart and that task name.
Aha. Okay. So thank you, Tway. That's exactly the answer that I'm looking for. And that I think is the context of what they talk about in terms of recovery processes. Is it's basically what steps do we need to take to one, figure out why it did not complete, and two, how much did it complete, and then three, how do we continue from last time, and hopefully this time it will complete. So I think those are the sub steps of recovery processing, of recovery processes. Does that kind of make sense?
Yes.
So now the question is, whose responsibility is it, to perform all of these steps?
I would think the person who's running the job.
Right. Well, at GMB, when we run the job and let's say it failed,
Mm-hmm.
we will contact the developers in the back end, and we will wait for their instruction before we could uh, fix it.
Exactly, because
They're
because the
gonna send. Oh, go ahead.
oh, no, you continue. Go ahead.
They will send us a fix. They call it a fix, where it's in a like a process on how to fix the issue,
Mm-hmm.
and they'll give us codes to key, and then we'll key in the correct codes and fix it, and then until it's fixed. And that's how we do it. But we can't really fix it without the, we call it green sheets,
mm-hmm.
without the green sheets from the developers.
Can you tell me more about the green sheets? Like what is included in the green sheet so that you can enter the changes. What kind of changes are we talking about?
It's just, for example, like, let me see, codes we put the right, instead of, it's just a lot of changes to the codes that we need when we run the jobs.
Mm-hmm.
Instead, because when we run the jobs, we key in codes, right? And instead of that, I mean, we used the codes, regular codes that we use, but for some reason some jobs would fail because, like for example, in February there's only 29 days,
Mm-hmm.
and it should be 30 days, so it messes up the schedule, something like that. So we have to fix and kind of manipulate the JCL so
Mm-hmm.
it will be correctly, it will
Okay,
run correctly.
gotcha.
So
Okay, so if I understand correctly, the change is going to be, it has to come from the developer, because the
right.
system operator cannot know how to fix the job, because they never tell the system operator what the job is supposed to do either, right? So without knowing what the job is supposed to do, there's no way the operator can fix it. And I also think that it's not the operator's responsibility to fix the job. It's the responsibility of the operator to notice the job did not finish, notify the developer,
Right.
and pass along any type of useful information, and potentially take the input from the developer, modify the job, and then run it again. Is that
Right.
assumption okay?
Yes.
Okay. Um, so so here's the next question. Um, do they usually just fix the JCL itself, or are there times where they want to change the COBOL program, or whatever the source code is associated with the job, the program itself?
Oh, sometimes they would fix the COBOL program.
So in that case, do they resend the entire COBOL program, or do they just send the difference so that you have to enter the differences?
No, they would ask for information, like they can't access uh, the the actual COBOL program, so we
Mm-hmm.
have to send it to them,
I see.
and then they will look at it, and then they'll get back to us and say, okay, we fix it on our end, so now you could continue, something like that. But
Interesting. So the developers normally do not have access to the COBOL program.
well, because yeah, they have limit the one that's already in the system,
I see.
but they're the ones who develop it. It's just that they want to see what's actually in the system.
I see. Okay, I understand it. Because they are actively doing development, so the
Mm-hmm.
one that they have on their system is
Uh-huh.
the one being developed. And you definitely don't want to run something that is being developed, but they
Right.
have no idea which version is actually being run, so that's why you have to send the source code of the COBOL program
Right.
to them, so that it is matching exactly the one that was run earlier with a termination issue.
Right.
Okay.
Because we have a sometimes we have a turnover, like some people retire and they don't have that information, right?
Mm-hmm.
The new person doesn't have documentation about that job or the program, so they would ask, they cannot see it on their end, we have to send it to them,
Mm-hmm.
that part where it actually failed.
Okay. All right.
That's what I
Interesting.
know. That's all I know for now.
No, no, no. This is
Since I
very
just
useful.
started.
No, this is very useful information. This is very insightful. Sabira, do you want to add anything? Uh oh.
Sorry, I was muted.
Oh, that's all
Um,
right.
um, it just I didn't want to. I was came in kind of late, so from a developer's perspective, on our, let's say our end, a job goes down. Generally speaking, you have an on-call person, but you also have a production support group. Production support group generally, in my experience, would be the ones that notify the on-call quote unquote programmer. On-call programmer then notifies, well, they may or may not be the same person that made the last change of this program if it's a program problem.
Mm-hmm.
It could be just a bad file. It could be as simple as a bad record inside the file.
Mm-hmm.
A lot of times, if you have the authority, you could strip out the bad record and just put, hey, run it again, restart,
Mm-hmm.
run from this step, run from a particular step inside the JCL, and then it'll run fine. And you send the bad record back to the customer, whoever's providing you the data. It just depends on the scenario, situation you're in and what product or what type of job you're talking about. But if generally speaking, it would be the developers get, like at EDD, for instance, a developer could get called and it may or may not wait till the next day. But in my experience, the programmers were all on call. We took week shifts, 1 week on, and we first rotated around. And you just troubleshoot. If you got called in the middle of the night, you troubleshoot, because we were in those type of jobs that I had, they were really high end production, which meant the last end of production, meaning whatever we produced is what brought money into the company. So this is a little bit more higher end production control type situation. But it's even at EDD, it's like, well, checks don't go out the door. It's a big problem too. So, so yeah, the developer could fix it. We could do a temporary fix, put it in what we call a temp library. Could do a compile in a temp library, run the job from what they call at EDD an SPPR, or we can call it a temporary job if it's a program problem. But a lot of times it's it could just be a data problem, just depending on the situation. I mean, there's so many variables to this world we live in. When it comes to program, a COBOL program, or it could be alphanumeric data in a numeric field.
But shouldn't that be caught by some earlier process?
It should.
So the issue is actually with an earlier process. And does anyone elevate that issue to a different person and go like, okay, our data set is not the way it's supposed to be, and and basically diagnose the process of how the data set got to you guys with a with a record issue. So how is there a process to do that, or do whether
send the data back to the customer
Okay.
that provided it? Hey, you got your data is no good, or it's not up to the standards, that your record layout doesn't match what we were supposed to get. Whatever that record layout may be, may or may not be.
Okay.
And if it doesn't match, then it's definitely back in their court, and they got to fix it.
Okay.
That's also the safest thing to do too.
Mm-hmm.
Even though if you know what to do with it, it's still, that could come back and bite a developer in the rear. If you like, when we had the ability to strip records, as long as we had a management approval in my previous jobs,
Exactly.
we would be allowed to do that. But it'd be up front, and I'd email the managers, all of them, so you would be able to CYA the whole group. Hey, I stripped out this record. This is the reason why. Ran the job. It ran fine. Otherwise,
because the action of stripping out the record may cause its own issue, depending on what is being stripped.
Exactly.
Okay.
Exactly.
Cool.
When you're on call so much, you kind of get an idea of each type of system and its normal quirks that it might have. But here's the other thing: you got developers are constantly. We're always doing. Developers are always doing work. They're constantly making changes. The first line of defense is the on-call programmer. Well, they may or may not. They'll usually reach out to, hey, you're the last one that touched this program. Can you help me take a look at it? And if it's really a program problem, that last person that fixed, let's say it was a recent program, and it was just something that got by and it passed. You thought you tested it as good as you can, but it's still found a glitch, and then you got to fix it from there.
Now this is an interesting discussion, because I can tell you what is happening with the other apprenticeship group, cohort, the developer slash software engineer cohort, because what they are learning is a process called continuous delivery, and also how to verify programs. After they make a change to a program, they are talking about automated mechanisms that can basically run test cases against the changed programs to automatically qualify to see if a program is ready for production. And then there's also systems and tools that can be used to integrate the new code, the updated code into production. So that is what they're talking about on the other side, with the other cohort.
Yes.
So this is interesting because obviously if bad data or bad program gets down to production, get to the point where the operator can see a problem, in the process, it just did not terminate correctly. That means upstream, they probably can refine their um, program verification process, which can be automated to basically catch cases like that. And
Yes.
so in production, you guys won't encounter this type of issues.
Yeah.
Well, they have test systems, so whenever changes are made, they run it in a test environment before they load it into production.
Yes.
Right. So there are several aspects to quote unquote a test system. So having a test set up, which basically can be a snapshot of a database and that they can quote unquote play with, that they can run their modified program against, that's one aspect of it. The other aspect is, they have to know what the program is supposed to output and then compare the actual output of the modified program to the expected output of that program. And if they don't match, okay, then they cannot release the code. They basically have to say, okay, did we specify the correct output, quote unquote, correct output incorrectly, and that's why it's not matching? Or is the program actually at fault and outputting something that is invalid? Now they have to go back and fix the program. But they have to look for consistency. And then there's also one more concept, also not on your side, but on their side. It is called regressive test. And a regressive test is basically saying every single time you guys catch something and go like, okay, this code is not working, it's causing the program to, basically end abnormally. Whenever they, whenever the developer, get this, they are supposed to add at least one more test case to address the issue that is identified by you guys. So by doing this, by adding more and more test cases, each one specific to a particular problem that is actually reported, they would basically develop a huge, gigantic test suite, SUITE test suite, so that every single time they make a change to the program, they will run the entire test suite against the changed program. And the idea behind that is sometimes you can have one change that fixes one problem, but it reintroduces another problem. And this is one way to make sure that it cannot really be sure. You can never be 100% sure, but this is one way to help reduce the number of bugs that can escape. Um, it's also interesting. This is also from IBM. IBM actually did a study of how most people think when you fix a bug, the bug is gone, right? The bug count just decreases by one. That is not true. Depending on the quality of the developer, depending on the organization, depending on a lot of things, it is possible that for every one bug fixed, they can introduce like 1.1 bugs. In other words, by fixing and by touching the program more, they can end up introducing even more bugs into the program. But that is not your problem, okay? Because that's the problem on the development side and not so much the production side. But I just want to let this particular cohort know about what the other side are doing, so that so this can help make sure that the same bug does not happen twice, basically.
If I may interject too on something on that,
Go ahead.
is as much as you have unit integration and regressive testing, Let me take you guys back, and I'm not going to age anybody here but myself, to where production meant actual physical bills sent out the door. So when I worked for Sprint or American Express, before, well, in American Express for IBM was, the internet was huge. So that, let's not count that. But there was no such thing as this, e-bills and things like that. So if Sprint, I worked as a developer on the tail end of the production side of Sprint. So a good example of that kind of testing would be, not only did we test the system side, unit integration regressive, but we had to go all the way down to the physical paper print, to where you're looking at the screen. Yeah, it may look great on the screen, but I don't know how it looks on the actual physical form that it's supposed to go get mailed in the mail to. So we'd have to get a sample of the mail, and we'd have a separate team. The testing team would do all that, but they'd also get the physical printout that we would send to the printer, make sure it looked lined up all perfectly down to the very inserter machine of the envelope. So it actually lined up with the envelope perfectly from all the way. So you can imagine that's even more variables that were added in. So not that it's easier now. It's just, we are working smarter. It's just different types of scenarios you got to worry about. Yeah. And there are still a lot of physical bills sent out. I mean, there are, but it's just not like it's just not like it used to be, where that was the only way we received those bills. So yeah, but those tests, what you're talking about, Tack, and I didn't mean to go off on a tangent, is those testing scenarios, they keep adding, those things can keep growing, those test case scenarios.
Oh yeah, they're supposed to.
Yeah, and that's their job. Yeah, they have usually every every division, well, I mean, the part of every enterprise will have a testing environment.
Yep.
I mean, a testing group.
But there's a person called the test engineer.
Yeah.
Whose only job is to derive tests and tools to test, the software.
Mm-hmm.
Yeah.
Kick the tires.
We have a big unit for just system tests, and it's huge.
Oh yeah.
And before anything could go in production, it goes through them, and they build test scripts, and they test everything before we say yay, it's ready. So it's a long process.
Well, this all gets even more interesting if you think about kicks, and also how everything is now web driven, because up to this point we are assuming everything is a batch job, right? I mean, okay, the batch job did not run, right? I mean, we just have to collect, the app end code. We have to look at the code. We look at the partially finished job and so on, and there's a way to recover the whole thing. But when things are interactive, it's a little bit different. When everything needs to be up 24/7, 365, it's a little bit different, because now, when are you going to integrate the new code into the system? And when something bad happens, it's happening in real world. So so it becomes more difficult to test a system, because the interaction between different users, and how the system is operating, that also can throw wrenches into an application. And I can tell you, this is all very educational to me, because I have been a system administrator for a LMS, a learning management system, not Canvas. It's called Moodle. It is basically an open source LMS that I have chosen to use for personal reasons. And then later on, a whole bunch of other people decided, we want to use this system too. And then occasionally we would identify problems with the code. So I'm basically the entire chain of people. I'm the developer, I'm the system administrator, I'm the test engineer, I'm the customer support, and so on. So when I'm wearing all the different hats at the same time, it all get kind of blurred out. It's like, okay, I know what to do with this. I'm going to test it, and I will make sure that the code is okay, blah, 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 blah. And in the state environment, obviously, it's not like this. Thankfully, it's not like this. And so one thing that you guys can do is to understand the processes. And I'm not talking about the technical process. I'm not talking about, technically you run this tool first and then you run that tool and so on. I'm talking about, in terms of the organization, what is the flow of things? Okay, when you run a job and you notice that it did not terminate correctly, what is the next step? Who do you inform first? And so on and so forth. So understanding that whole process, I think is going to be, beneficial to this apprenticeship content. All right, so
Absolutely.
yeah,
Absolutely.
yeah, because this is all new to me, so I'm looking at everything with the eyes of a child.
No, you're doing very well. It's you're I mean you know it, but you're going back to the foundation of all these concepts. That's all. That's all it is. The foundation of the concepts of data, basic data processing, information technology, where it came from. The one thing that started lacking was the opening up of the security part, is where a lot of new platforms started losing sight of. That's where a lot of it.
Yep.
That's what and that's where they got a little bit too happy with themselves, and let's just keep. Well, now you got opened up a whole new world of access to everybody, and you don't realize what you're creating a whole new. Well, it's creating a lot of new great jobs for a lot of security people. That's for sure. So that's, you could look at it a lot as the silver lining in a lot of good ways, in a lot of different ways.
Yep. So Bert, you're gonna have a chance to talk about that, because that's actually included in our topics. The very last topic is about security in ZOS. It talks about system security. It also talks about network security. So that's one of the topics that we have included in these topics. So I'm just going to circle back to problem determination tools. Okay, so does anyone know what tools are available to determine what is causing an issue, and to what extent can you determine the cause of a problem?
Well, like I said before, you can go to the error code in the job output and put a QW for the help
Quick reference.
quick ref to come up to help you diagnose what the issue is. And then you also have, when you make a change to your JCL, you can always run a JJ on it to make sure that there's no errors in the JCL.
So when you say there's no error with the JCL, are we talking about syntax issues, or are we talking about potentially other issues with the job?
ProJCL is, when she refers to JJ, it's a product called ProJCL.
Oh, okay.
There's a lot of them out there. There used to be, what was before ProJCL? GEM. We used to type JEM at the state. It's syntax tech for the most part. They can get pretty. They configured ProJCL pretty good now to where it'll actually tell you could try running this job. I'm totally paraphrasing the syntax. You can try running this job, but you don't have authority to this data set. It'll actually tell you that. So before they didn't have it that fine tuned. So at the data center they have that going at CDT. So
interesting.
Yeah, it'll actually tell you ahead of time, hey, you don't access. Well, there I go. If I run it, I'm going to get a RACF security error.
So this is good, because then I have another question: is who is going to run this tool? Are we going to run this tool before the jobs are even submitted into the system and scheduled, or are we, do we let the system run, this tool when the job is scheduled to run, and then it doesn't run, and then we just get back to the developer?
The JJ's ran on the JCL to check it before you submit the job. But then, like on my end, like when I go in and do system checks, like on S1, that sounds like Sabir works on, then I can tell when there's a rack F, when somebody's trying to access one of our data sets that they don't have authority to access. And then I also get notification of that because that has to deal with the rack F and not having the authority or access to the data set that they're trying to access.
Yes.
So that sounds like that's a very good topic for security in ZOS. Is how ZOS manages access control. That would be system security.
Mm-hmm.
Cool.
And also, the JJ, like Carrie brought up, when she says JJ, it'll tell you if, let's say, on your parameters on your JCL, you're doing a new catalog delete parameter for a data set being created. Well, if the data set already exists, it says, hey, this data set already exists. So, it's so it won't, unless it's depending on the disposition you choose for the JCL. We won't get into all that, but I'm just saying it'll tell you the data set already exists. And it's being defined as new catalog delete. So
that can potentially be it can potentially terminate a job depending on how the job is set up. Interesting.
Yes.
That's very interesting, because I come from a Unix slash Linux side, where there are a lot of system functions that says if the file is not already existing, it will be created. If it is already existing, it will just be overwritten. In other words, it is not something that there's no such thing as JCL in the world of Unix. So without a JCL to specify and go like, okay, we have to check the existence of all of these files. These are going to be created, these are going to be read, and these are going to be modified. There's no such thing. Okay, it's all built into the program itself, which is more or less equivalent to the COBOL code in our context here. So as a result, a lot of programs, if they see, even if a file is already here, the file open command, in a program will basically just go like, oh, the file is already here, but since you're reopening the file for write, I'm just going to overwrite the original file without any warning, without a way to catch it, unless the program, which is equivalent to a COBOL program in our context, writes specific conditional code to say, okay, if the file already exists, then we're going to do it this way. We will just exit out of this program with a code and stuff like that. So the main difference is in the case of an IBM mainframe computer, they leave a lot of clues and they leave a lot of information to the system operator and also to the system to catch potential problems. So even if the COBOL program itself is not written very carefully, as long as the JCL that is wrapping around the job itself is properly set up, they can still catch a lot of things that is not supposed to happen. In the Unix world, that is not the case. That is not the case. And I can tell you, it is not just a programming language issue. It's not just the operating system issue. It is a culture issue.
It's a culture issue, absolutely.
Yeah, it's a culture issue. So when it comes to C programming, there are a lot of ways to program in a bad way. And so you can be a very sloppy programmer in C and C++, and the program can potentially do pretty dangerous stuff without the operator has no chance of catching those things. And in this environment, in the ZOS environment, the operator actually get to be able to oversee a lot of things and make sure that things are happening in the right way. So I'm going to ask the last question. I know we are pretty close to the end time of tonight's lecture, so I'm going to ask the last question here. So the question is, do you guys make backups, of data sets that can potentially be modified before running a job? So that way, in case a job, fails miserably, you can still say, well, it's okay. We got the file, we got the data set backup. We just need to rerun the job, with a fresh copy of the data set.
I could tell you this much. I've performed my own upgrades on upgrading a database to a new version, and the job steps in doing the upgrade is we have to run a backup twice within the process, because if something goes wrong on the upgrade, we can revert back to what it was before the upgrade.
Okay, so my follow-up question, I know I promise I won't ask again, but I'm just filled with questions. So the follow-up question is, once you back up the database, did you try to use the backup and restore that on the test server?
No, because when I'm doing it, I'm either loading it on a test environment for a customer, and then the customer tests the test environment, and once the customer gives me the okay, then I go and do the same process to their production environment.
I see. Gotcha.
So it's just for my steps that I'm doing on the upgrade to, if I make an error along the way, that the backup is done, so it can be restored to the beginning of before I started the process of the upgrade.
Okay, interesting.
So I don't, I mean, I'm on the mainframe and the customer has their stuff, but I'm just upgrading the version of the database program that they're using to a newer version. I'm not actually working in database, which
but
is
you
a
are
database.
following the steps to back up the data in the database before you upgrade it.
Yes.
Okay.
Yes.
Now, in terms of accountability, Carrie, do you have any way to show that you follow the steps correctly? In case something happens, how do you make sure that they do not come back and blame on?
I have two ways that I do it. First of all, we have an actual paper document that has each step along the way. So I have to make notes on each step, like whenever I run a job or whatever I'm touching, I have to copy the file name after the job's run with the job number, and I paste it into my document. But another way that I can do it also is because I work with a coworker that I'm actually sharing my screen through Teams, and I can actually record it. So then I see every step I'm doing along the way.
That is very smart.
So, yeah.
Because, for several reasons. Yeah, go ahead.
Yeah, I'm clapping for it because that recording, that's one thing that we've learned in the pandemic. We've all used WebEx, Zoom, all these tools, but the recording part is something that's really come in handy during this pandemic with our coworkers, and because
that's how I'm getting my training. I'll meet with one of my mentors through Teams, and I actually have to record the training, and then I have to go build my own notes from it for when I'm doing it by myself, and then I'll have somebody sit with me my first time. And then I do ask another coworker, she works a different shift than me, but she's still learning too. So she'll sit in with me, for a second set of eyes, and we'll record it. So then I have each step along the way. And then if, she wants to refer, I've shared my notes, I've shared the recordings with her. So then she has access to that for her, reference.
It takes longer, but you get more concise notes doing it that way. With a recording, you can go back and go, oh, let me fix something here. I've definitely noticed a lot of the team members also making better notes because of it. It's a lot more work, but
it's not.
But in the end, it's not more work.
Exactly. All right, this is cool.
It helps with turnover. I mean, any type of, continuity planning, contingency planning, or people retiring, or let's say Carrie retired tomorrow, she'd have these recordings available somewhere on the shared drive with notes, or whatever have you. which is a
Well,
good thing.
well, a potential problem, because it is, there'll be too many recordings. No, I'm not kidding. There'll
I
be.
No.
know. I've seen that happen too. I know. I go.
Well,
Go ahead.
I actually keep the recordings for each environment that I upgrade within my file for that environment.
Mm-hmm.
So
So it's
I
organized.
have, yeah, in my email.
Mm-hmm.
So
Yeah, but it can still get, it can still get to the point where it is difficult to retrieve an earlier video because, you can do it by date, you can do it by category, you can do it by type, but each way, you can only go so far with that. I think eventually it has to boil down to tag-based, a tag-based system. So every time you put a recording into the system, you have to tag it in addition to, being able to retrieve it by date and also by the type. Now you can also have a tag, that is kind of more of a free form type of comment, but it's searchable. So I think, that's going to be something that, that's going to happen.
That's a good point. Yeah.
it stays within the actual team meeting. So you have a header on the team meeting, and the team meetings don't get erased, and then it actually emails you the recording also.
Right.
So I can put the recording email with the product that I'm working on, and I can always go back to the team channel to review the recording later if I need to.
But when you have too many of these meetings that had happened in the past, it, at least for me, I would have I would have a problem with, remembering in which meeting, which product was mentioned. So, there'll be a whole bunch of meetings. I know it's one of those meetings that, this particular topic was brought up, but I would have a problem, of, remembering which one of these meetings that particular topic was brought up. Does Team do automatic closed captioning?
No.
Got it. Because if it does, then the closed captioning is basically a text representation of the content of the meeting. Then it becomes searchable. That can be a very, very useful tool because now you can basically use a search engine like Google, kind of search engine, and you can basically look for keywords. In which meeting did we mention this word and that word and that word, and that person was also in the meeting. That makes it that makes it easier to locate, a particular recording.
That would be cool.
That would be cool. Yeah. All right. Go ahead.
And saving in teams. And Carrie, you guys at CDT would be someone to ask like this, because I know, like with vendors, let's say CompuWare, for example, they use WebEx, and they'll have like recordings where they'll say, hey, this is what you do when this problem happens, and we'll record it, but they'll send me the link. But I've noticed in the past, saving these links, sometimes they'll save it on their server, but they'll only save it for so long because they got 1 million customers. So there's a time date on that. Otherwise, their storage people, they go, it's over, it's gone. So then if I save it to my own drive, well, even on our shared drive, so they start seeing a lot of recordings. Sometimes the network folks just take it upon themselves to just start slamming those out of there.
Oh man, that is bad.
I don't know about that, but like I had a virtual training through Software AG, and I know like on their webpage, I actually create an account, and then the recordings for whatever trainings or anything that I do get saved to my account, so I can go rewatch them whenever I want to.
Beautiful.
So.
Beautiful.
Yeah. Okay, that's kind of cool.
Yeah.
All right. So
these are all good ideas. Yeah.
Yeah, absolutely. I really like the format of today's class. It's more of a discussion, and we thank you, Carrie, for contributing because the discussion is mostly
I'm sure Twee could offer how she does her software updates and what her steps are. Twee,
I have to hear the question again.
like how do you keep track of when you're doing an install? on this each step that you're doing?
Our unit don't show me how to keep track for in case of an error and someone come back and ask me, but we do backup data like any production that the install. We have the original copy from the vendor, then backup, and then another backup. We work on the first backup, and if we mess up on the first backup, we copy the second backup to the first backup and edit that.
But in these scenarios, it is important to make sure that the mechanism that you're using to backup is restorable. Um, because the worst thing that can happen is thinking that you have backed up, but the actual backup is not usable. You cannot use it to restore the actual data. I have seen it in the past. That's why I mentioned it.
Oh yeah, these are all we've all. If you haven't been through the pain, it's unfortunate, but it's the best way to learn.
Yeah, I have seen people trying to back up a database when the database is still up and running, and what they're backing up are the files corresponding to the database. So that is only a small part of the actual data in the database, and as a result, they thought that they thought that the database was backed up, and when they had to restore the data, they found out that just by restoring the files corresponding to the database, in this case MySQL, was not enough, and they basically lost the whole thing. Basically, the whole thing was lost.
Nightmare.
That's step number one, TAC, is to notify the command center that you're bringing it down. Then you have to bring down the database, and then you have to go make sure that the database is down before you go any further.
With modern databases like DB2, there are ways to back up at least a portion of it without having to shut down the entire database. DB2 is what we call a SQL database that's capable of using transactions, and as a result, there is a way to tell the database and say, I want to take a snapshot now, and what it will do is it's going to lock all the data up to this particular point, and it will be self-consistent within the database up to this time, for backup purposes. But all the same time, the database is actually still functional, so there will be additional queries coming in. There'll be new updates and whatnot. Those just won't be recorded as a part of the backup, but the database itself is actually backed up in a consistent way. So depending on what you need to do, with the backup of the database, whether it's a system-wide, recovery image, or whether it is just for a few tables or just for a few databases, it has to do with the granularity of your backup. But modern databases are very sophisticated. They are designed to be up 24/7, 365, with the ability to be backed up, for legal purposes and also for data recovery purposes. So it's a whole different topic, there.
Yeah, I know. There's automatic daily backups and
Yeah.
there's automatic monthly backups.
Without having to shut down the system.
Yeah.
Yeah. So database is a specialized area, and that's why they have DBAs, database administrators, whose only job is to deal with the database.
That's me.
Oh, that's you.
Yeah.
Yeah, but I think there was one discussion where someone brought up that the DMV cannot afford to have much downtime because the sheriff's department and a few other departments may need to look up DMV records. And the same is true also for Wells Fargo Bank, is true for American Express. If you think about American Express and just think, how much money, how many transactions would be basically not doable if they had 1 hour of downtime, to shut down the whole system, back up a database, and then bring it back up. That is just not something that they can do. And
Well,
yet,
like in those type of cases, from what I understand, is like we might have it on, like, let's say we have to do like our upgrades when like the IPL is happening. And when the IPL is happening, their actual system is moved to a different LPAR, so it's
Yep.
still up and running.
Yep.
And then it's converted back afterwards. So that's why it's 24/7. So they're either on another LPAR still able to work, or they're on the Vacaville side. They get converted over to the Vacaville side so they can still, which is the actual mirror copy of what they have. So then like the sheriff's department and everything can still access it while the IPL is happening.
But
Or
what about the backup process? Is it backing up the one that is live, or is it backing up the one that is not live?
it backs up the one that's live, and then it's like a 2-minute difference to the Vacaville side.
Oh, okay, I
So
see. Okay.
and yeah, and then like yeah, so it's a mirror, it's a system that's constantly mirroring
Mm-hmm.
the live system.
Yep.
And
Okay.
then like when the IPL is done, then there's like, I'm not sure, I don't know all the concepts yet, but there's like a P log to where it's a placeholder if something's happening, that the new transactions can go to the P log
Okay.
and then be put back in the database after it's back up.
Mm-hmm.
So stuff like that.
Yeah, I built a system like that, with a server running on in my office and another server running on in my studies, and the two will basically self-synchronize. But I couldn't do it, with only like 2 minutes of lag time behind. So mine was, I think, half a day. It was 12 hours behind. That was when I was implementing the system for in Moodle for it's a learning management system. So in the worst case scenario, it would lose half a day of activities.
Yeah.
But it was fun. It was fun to it was fun to get that to get that to work. I actually had to put the boxes together too. Those are all the PC stuff. So I had to assemble the motherboard, the RAID drive array, and all the whole 9 yard. Yep, that was interesting. But it's irrelevant to this discussion though. All right. So
Great
Sabira,
stuff.
on Wednesday, what do you want to do?
If you don't mind, with
Mhm.
tech, can we continue this format until I'm completely and I'll help wherever you need me on the side. I'll do everything on the side that you need me to do behind the, whatever proverbial curtain you need me to do, as far as research or whatever. And the reason why I say that is just because so I can get time to get over and get a loaner laptop or ring my network people's in necks downstairs.
Okay.
um,
Okay. So
whatever will make it easier for you. I know you got a lot of things you're doing, so.
So we are caught up in terms of time, because if you look at my screen capture or the screen share, today is the 3rd, and we have up to the 5th to finish up termination and recovery analysis. We didn't quite touch on problem determination tools. So if you have experiences with that topic, we can. So I will let you be the lead of the lecture on Wednesday. Would that be okay?
That'll be fine.
Okay.
Is there anything specific you want me to talk about? Well,
I wouldn't. I wouldn't know because I haven't done the actual research yet. So these are the actual topics coming from the curriculum of this class. So all it specifies is, we need to talk about recovery processes. We need to talk about problem determination tools. So whatever problem determination tools you are familiar with, and whatever it comes with ZOS, those would be all good topics to bring up on the lecture on the 5th.
Okay.
And I can.
Is there Twee and Carrie? You both work at CDT, or is Lupe? Does everybody work at CDT, or am I the only?
Kelly, Twee, and I, and then Lupe works at Franchise Tax Board.
Oh, okay.
And then Jennifer works at DMV.
Gotcha. Well, that's good. We got a little spread out here. Okay. It's good to know. It's because then when you say DMV, I'm thinking like if I brought up the version tool change manner a minute ago, and that's a good backup without going on a rabbit hole tech. Like let's say you have a version control tool. Let's say I installed the program and this thing lab ended, went nuts in production the first day. I can immediately just do a back out of that and just revert back to the original, the -1, what we call the -1 version in that tool, the -1 version, or -2.
Are you talking generations?
Yes. Well, basically generations of the actual program itself, version, which would bring back the load, the prior load and the prior source code.
Okay.
So yeah, that's ChangeMan's tool. There's a million different tools out there. I mean, ChangeMan's one of them. A lot of companies do homegrown ones. Endeavor is DMV. We got somebody from DMV.
I've heard the word Endeavor thrown around my unit.
Yeah.
It's one of our products, I think, because DMV, I think, is on AdaBase.
Yes. And I know at one time, I think EDD was on AdaBase, and for whatever reason, it fell off. I think if it was up to our DBAs, they'd want it in a heartbeat. But I don't know what kind of politics or whatever happened back then. It was like right before I got there. So yeah.
And just so that we can relate these to modern terms, not that you guys are not modern, but IBM products on basically its own bubble. It's very disconnected from until now it's very disconnected from the rest of the industry. So revision control is usually done by GitHub these days, or the program that can get a job done is called Git, Git, Git. GitHub is a web presence, is a website where people can submit their code, so that everything is is in the cloud, so to speak. So those are the tools that people who use Unix and Linux tend to use for revision control. Just so that when you hear those terms, you can relate it back to the tools that you're using.
Exactly.
All right. So I think we are good for today. And I will communicate with you, Sabir, just to get some ideas of what we will be talking about on Wednesday. And then from Wednesday to next Monday, we got a good stretch of time, and that's when we can kind of plan out a little bit more for the upcoming topics.
Okay. Sounds good.
Yep. Okay.
And let us know about if IBM can get us a sandbox to work on.
Yeah, I will mention it. I'm gonna mention and ask tomorrow, but I really suspect that nothing can be done during the course of this class. But I will ask them. I will ask to see how much lead time they need to set up sandboxes. And we'll talk. Yeah.
Oh, go ahead, Carrie.
We have access to test environments that we can play with. We've used them for our other classes.
You mean with CDT, or is it a resource?
All of us.
I was just getting ready to ask that. I'm glad you went there.
Lupe had a couple of problems on some of his assignments that he had to work out with our instructor individually, but Kelly, Twee, and we have Sci9, which is our test system that we can use, and Jennifer, I think Jennifer had access to a test environment as well. So
actually, I go straight to the mainframe system. It's not a test environment, but I just use it. My mentor told me you could use it as long as it's under your dataset name.
So yeah.
So
yeah, because OTech would host trainings, and when they would have enough people, and they'd have COBOL classes, they'd have vendors come in and teach there. So I think that's probably the test bed you guys, Sci9, you said, Carrie? That's where they were probably doing it.
Yeah, it's Mainframe University is always on Sci9.
Yes.
Okay, that's what I was. Mainframe University should be something they should throw at you, TAC, for free. No questions asked. And being I worked for IBM at one time, this is where I get mad at IBM, and I love the mainframe, but this is why you probably became so skilled in college at all these client server tools, is because, well, it's a business. I said this in our interview. Colleges teach whoever's throwing them the free stuff and all whoever's giving them the money. Let's face it. Well, IBM became so big and arrogant over the years. Well, we'll always be needed. Whatever. In the meantime, there was a whole slew of generation of kids learning all these open source development.
Exactly.
And now you have geniuses like TAC here who can create servers on the fly.
Oh, not on the fly. Try a few weeks.
But I mean, it's just because they were so hardened in their old ways. But yeah, she's right. The mainframe university should be something available. All these or bring this up too. If you and Mark talk, and I'll even talk to Mark offline.
Well, we'll see if you can make it to the meeting, because I think that would be very
Feel
helpful.
free to invite me. I'll be glad to join. I'll tell my boss and everything ahead of time.
Let me ping Mark and let him know that we should invite you too, because that was arranged before we had these conversations. So let me do that.
Because there's a lot of training companies like Themis out there that have these virtual access to a virtual mainframe, which is basically mainframe university, another equivalent of that. It's a sandbox. It's really it, and you can kind of configure these test box scenarios for each class, what you're teaching.
Well, we all have access to our mainframes that we can use for class. So.
Yeah. So they already have the Sci9. So yeah, if that's a test bed, then me and you and Mark should get our heads together on that tag so we can make it.
Yeah, I just sent him a Discord text, and we can also communicate by email. So I'll do this offline after class today.
Got it. Sorry to keep everybody. Sorry to get on a tangent here, guys.
No problem.
I'm learning more from you, believe me.
So the CDT's Sci9 sandbox, we can use it to test, but I don't know about IPL.
Oh no, we can't do an IPL on it. No.
That's why I just I brought it up earlier with about IBM, because possibly if we have to do IPL, then we might need their sandbox.
Well, I know, like Twee, when we had our IBM training through IBM, they gave us access to their mainframe, but I don't think anybody's gonna let us do a simulation of an actual IPL unless it's just a dummy program.
I have seen it done, and I have done it before, but how involved it really is, that would be a total guess on my part. It looks good though when they had us test it on virtual, but it's been years since I've seen that happen. But as far as how real it truly is, probably just basic dummy information. That's probably it. But it does simulate the whole process of an IPL happening, so
there's nothing out on the web that would do that. No.
I heard of I forgot what's the guy name. I heard it from when I was taking IBM training class. Tom or someone. He create
Tom Brennan. That's who you're thinking of. Yeah, Tom Brennan.
He create a similar emulator like TN3270, and he charged people like $35 for that one-time use, one-time pay, and you use it anytime, unlimited.
It used to be totally free too, but yeah, he charges now. But it's kind of cool, Tech, what she's talking about. Tom Brennan's his terminal emulator. If you use it, you guys could actually use it at work too. if you wanted to. You guys
Oh, the
could do
terminal
that.
emulator is it? Yeah, I know that one.
Yeah,
It's
and you
that's
can actually use your mouse to scroll down through the mainframe as opposed to just constantly hitting PF8 all the time. So,
okay.
Yeah.
So I just sent a message to Mark and see if we can include you in the meeting tomorrow. I think it's let me check the schedule so I can let you know about
let me
the
check mine before I get out
about
of
the
control here
time.
with this. Yeah.
Yeah. So are we okay with concluding the class? So the
Yeah.
Yeah, these guys, I know it's
I'll-
late.
We'll leave. You guys can talk. How's that?
okay.
All right.
Okay.
I
They
mean, you
don't wanna
guys can
hear me.
stay too. We are not going to talk about anything in secret. I mean, it's just
No, I'm
boring
good.
stuff.
I'm good. I'm hungry.
Okay,
Thank you
go
guys. You
go
have a
eat.
nice night.
Okay,
Bye.
Bye.
okay,
Bye.
bye. Yeah. So the meeting tomorrow is